Hello, let's continue our Sudoku adventure with Kinetix by Riffclown. All right, well, we have irregular 6x6 Sudoku rules. What does that mean? Well, we still, in each row and each column, we still place the digits 1 to 6 exactly once each. But instead of having our normal 2x3 boxes, instead we have these irregularly shaped regions. Sometimes it's called jigsaw, because you can kind of see how they kind of snap together like a jigsaw puzzle would. And so these work the same as boxes, they're just a different shape. And you can use the bold outlines to determine those shapes. And so the point is that within these, we also are placing the digits 1 to 6 exactly once each. But where our normal boxes are, there's no restriction because there's no bold outline there. All right. We also have arrows in the grid. So that's these arrows connected to a circle. The digits on an arrow sum to the value in the circle. So if this was 2, I guess I can't put 2. Anyway, let's do it down here. If this was 2, 3, that would add to 5. So we put a 5 in the circle. Arrows do not prevent repeating. We just kind of mentioned that because some constraints do prevent repeating. The arrows do not. So, for example, I could put a 4 here and a 4 here. It would add to 8, which doesn't actually work because there's no 8. But I couldn't find a digit to actually repeat that would work. Anyway. That is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, actually, I do want to look at this because this can't be 1 or 2, so it's minimum 3, and this can't be 2 or 3. So if it was not a 1, it would have to be a 4, and that would give us 4 plus 3 is 7. 7 is not in the puzzle. So this has to be a 1, and then this has to be 3 or 4 or 5, which makes this a 4, 5, or 6. You can see my point that if this wasn't 1, it would be a 4, and then because of the minimum here, we'd end up overblowing our sum. So it does force that 1 there, but it doesn't force this to be a 3. It can be bigger. All right, this column needs a 1, and we've placed a 1 here, which takes it out of the rest of this region. So one of these two is a 1, but I can tell you we're not adding to 1 with two digits. So the 1 ends up here. And that means that these now can't have a 1 on them. In fact, you know what? I think in today's puzzle, I don't know if I'm going to do much coloring, so I'm going to just color each region, which is going to make it easier to talk about the regions and also to scan them. So this is a really nice technique for those who would like to do that. All right, so now you can see that yellow already has a 1, so these can't be a 1. And so the minimum is 2, 3, which would add to 5. We can also add to 6, which would be a 2, 4. So the 2 is definitely in this, on this arrow, because we can't do 3, 4, 7. And let's see, what else can we do? This 5, 6, where does it go in gray? Well, it can't repeat in the row. Whatever this digit is, if it's a 5, where's the 5 go in gray? If it's a 6, where's the 6 go in gray? Well, it's not going to repeat in the row. So it's going to go right here. These two are the same digit as each other. This 2 actually gave us a 2 right away, and I didn't notice it. But where does 2 go in this column? Because it can't repeat in the orange, so the only place 2 can go in the column is exactly right here, to be in the right mode. All right, these two are in red. Okay, so if we didn't use the 1, our minimum would be 4, 5, which is obviously bad. That would add to 9. 9's definitely not this puzzle. So we definitely have to use the 1, but this can't be a 1. So the 1 goes here. Can't be a 1 because of the row. And so now we're going to be adding a 4 or a 5 to get to a 5 or a 6. In fact, this whole row is just 4, 5, 6. That might be helpful to mark. All right, over here we have 4, 5, 6 as well. We'll mark that just for the rest of red. What else have we got going on here? Is there any more geometric deductions? Okay, yeah, so these two yellows, where do they go in green? Well, we already know the 1 goes here. And so this 5, 6, again, needs to go somewhere in green, so it's going to end up right here. This can only be 5. These are the same digit. All 3 of these are the same digit, in fact. So what I'm going to do is I'm going to mark those just with an A, just to remind myself that all of those are the same, because I used the color for the regions. All right. Do we know anything about A? Yeah, so we, well, maybe. Oh, we know something about this column. Where's the 3? It goes right here. But I was thinking about A in this purple, because this A takes it out of, actually, this A takes it out of all of these. So A is one of these two. Oh, yeah, okay. This A does all of the work. It can't be here, and it can't be here, and then this is a 1, which we know A is 5 or 6, so it can't be 1. A given can be A, but in this case, we know A is 5 or 6, so a 1 cannot be. And so this is A. And that resolves A, right? Because we know this can't be a 6. So all of our A's are actually 5, which is huge, because that makes this 1 plus 5 is 6. These are not 5s. Clear these out. This is the only place for 6 in this red region. Oh yeah, A is 5. I missed an A. That's 4 and 6. That makes this a... What happened here? The 5 gives us the 4 and the 5. These aren't 4. Yeah, 2 plus 3 is 5. That worked out. This is a 6. All right, I think we're just plonking now. Where's a good place to plonk? This is 2, 3, 4. Maybe not the best place to plonk then. These are also 2, 3, 4. It's not a 2. This whole row is 3, 4, 6. Yeah, where's the 6? Right here. This is 3, 4. We need 2, 3, 4 in this purple. This is the only place in purple for 2. That gives us 3 and 2. Just clear these out. We get the 4 and the 2 over here. Bunch of 3, 4s. This is also 3, 4 for purple, not a 3. So that's 4, 3, 4, 3. Down, 3 in the corner, celebrating. That's a 4. We get the 1. We get the 6. We get the 3. And the final digit is a 1. And we're done. All right. As usual, a very nice irregular geometric Sudoku from Riffclown. I enjoyed that. It was cool to find all the different A's in the grid, as I called them, and then having it end up here. This is a very powerful cell right here because of how it sees this purple region. None of these can be the same as this cell here, and we proved it wasn't 1, so these had to be the same, and that forced it to be 5. That was really neat. All right, well, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.